So let's go over the last array-based topic for this module, which is multidimensional arrays. Multidimensional arrays are arrays that have multiple dimensions. So far, we've been learning about arrays that just have a single dimension. The best way to view multidimensional arrays is that you can think of them as matrices for 2D arrays, and then scale up to higher coordinate systems. For this course, we are mainly dealing with just 2D arrays, so that's what we're going to deal with. And you can think of them as matrices. So let's go ahead and learn how to just create them first, and then we'll go into how to manipulate them a bit more. We'll write a method concerning them. Okay, so let's go ahead and create a, we're going to learn how to create them, and let's just go ahead and say, let's go ahead and do a public static, and right now it'll be void add an add method. Okay, so public static void main. We are going, so how do we create a 2D array? Well, this created a single dimensional array right over here with int 5 spaces inside of it. Fairly straightforward, right? So a 2D array that is 5 by 6 would be made like this. This creates a 2D array, right? And we know it's 2D because there's two array bracket symbols over here. And how big is it? It's 5 rows and 6 columns. And so let's see what happens when we print this out. Again, if we print this out, by the way, just like this, it'll say it's an array of arrays of integers at this memory location. If we use arrays.toString on this, it's actually going to be also not useful. But in some, at least not for printing out, but it is useful for analyzing what it's saying. It's saying that it is an array, and these are the elements of the array. This element is the first element is an array located at this memory location. The second element is an array of this location, and so on and so forth. So actually, a 2D array is an array of arrays, is the best way to think about it. Each item right, is an array, okay? But at index 0, you have array. At index 1, you have another array. At index 2, you have another array, and so on and so forth. Imagine that that you've got basically a filing cabinet, right? You can view that as an array, with the top one being index 0, the middle one being index 1, and the bottom one being index 0, right? And then in each filing cabinet, you can pull out, and it has its own folders inside the filing cabinet. First folder is index 0, the second folder index 1, so on and so forth, right? And if you open up the middle one, it has its own folders with index 0, index 1, index 2, and so on and so forth. And then if we open up the bottom one, which is index 2, it has its own filing, it's its own folders, which also, and each of the folders have their own papers. That's kind of describing a three-dimensional array right there, even though it's something we use all the time. So using a metaphor is kind of useful, but here, view it like a matrice, rows and columns, where this is a row of arrays, another row, another row, another row, and another row. So let's actually go ahead and actually print it out in a useful format. So for int, let's go ahead and say int I is equal to 0. I'll give it better names later. Int I is less than array.length, so it's exactly the same as we've been seeing so far. I++. And what we'll do out is we'll print out arrays.toString array sub I, the ith element of the array. So we'll print out 0, then 1, then 2, then 3, then 4. And we get index 1, index 0, which is a 6-length array. It is one row with 6 columns in it, a second row with 6 columns, a third row, a fourth row, and a fifth row. 5 rows, index 0, 1, 2, 3, 4. So it looks like a matrice again, but this is an individual. Index 0 is an array of its own stuff. So let's go ahead and populate it a bit. Maybe we'll go ahead and say, hey, index 0, so row 0, column 1 is equal to 5. Row 2, column 4 is equal to, let's go with single digit numbers to keep it nice and evenly spaced. Row 4 is the maximum row I can get, and column 5 is the maximum row, right? Because it's a 5 by 6 is equal to 9. So now if we print this out, we note that row 0, column 1 is 5. Row 2, 0, 1, 2, column 4, 0, 1, 2, 3, 4 is 2. Then row 4, column 6 is 9. And a mildly frustrating thing you might note is that row and column don't correspond to x and y. It's reversed, right? Right? Don't correspond to xy coordinates. Also, this is 0, 0. The top left corner is 0, 0, which actually is the way it always is in computer science, because of this way that arrays are structured. But top left corner, but anyway, rows, this is a row, this is another row. So the first coordinate is the row, the second coordinate is the column. Now over here with our for loop, let's go ahead and explain there. Array.length, how many items are in the array? Well, there's 5 items in this array. There's 5 arrays in this array. 5 subarrays, if you will, in this array, each of which is 6 long. So the answer isn't 30, it's 5 because there are 5 subarrays. Okay, so let's go ahead and mute the distant audio. So let's go ahead and look at how we can play with this. So and here our 2D arrays are going to be indispensable. So let's go ahead and, or rather our nested for loops are going to be indispensable. So let's go ahead and create a add method, which will add 2 two-dimensional arrays together into one, right? And we'll return that new, rather than modifying one of these, we're going to return a new 2D array. So so our arguments are 2 2D arrays, and our return statement is a 2D array. So first thing we're going to do is that we are going to need to assume that basically that both A and B have the same number of rows and columns, because otherwise matrix addition just doesn't work, right? So what we do is that we figure out, okay, for int I, or for int row is equal to 0, row is less than, or rather, let's go with row num, because we might want to use the actual physical row. Row num is less than, row num is less than a dot length. Row num plus plus. So row num is I, it will start at 0, then it will go up, and it will go through 0, 1, 2, 3, 4, however many there are. Row num plus plus. Then for, and then we'll go ahead and say for column int column num is equal to 0. So now we're iterating over the columns. For each row, we need to go through each of the items in the row. So for each column in the row, column num is less than, not a dot length, because that's the number of rows, but we're in a row right now, so a row num dot length. Oh, that's weird, right? Col plus num plus plus. Okay, there's a lot to parse there, but before we go on, right, column we're setting up just like we would row, and we're saying, okay, what are the valid column numbers? They're from 0 to the end of the column. 0 to the end of the column. Well, how long is a column? Well, we need to get a row and ask how many items are into it. So we get the current row we're in and ask how many items are in it. That won't change. Remember, arrays, the length of arrays is immutable, but the contents aren't. So column number is less than the number of items that are currently in the column, that are currently in the row. And then what we need to do is that we need to create a new array that's the same size as A and B. So int array C is equal to new int. Again, how long is it going to be? It is going to be a row. How many rows are there? Array.length. And how many columns are there? A.length. Or rather, A0.length. In other words, again, all the rows are going to be the same length. They don't have to be. You can get jagged arrays. But in this example, they're going to be the same. So A0.length. So how many items are in a specific row? How many rows are there? How many items per row? That's what we're asking. C row num col num is equal to A row num col num plus B. I'll learn how to type one of these days. B row num col num. I typically ask this as a question for for students who are taking a Intro to Java class as a homework question. So we add these items together, set it up, and return C. All right. Let's go ahead and just do one more pretty straightforward one very quickly over here. So let's just do our one that we've done already, but for single dimensional array, public static int sum. This one should be much easier, which takes in a 2D array, right? And so what we're going to do is we are going to do pretty much close to what we did. So int sum is equal to 0, and we will return sum at the end. So first we have to go through all the numbers in there. So for int I is equal to 0, I is less than r dot length, right? Typically we use I and j. But here what we can do is that we can actually make this slightly easier to read. Rather than like doing this whole nested thing, right? There's a couple ways we can do this. For r dot length of I dot length. But this gets, kind of messy looking, and that's kind of frustrating, especially this part. I know this part gives some students some headaches, right? Sum plus equals I R I J. But that's valid. But again, like I mentioned, that gives some people headaches. So what I'm going to do over here, and this will hopefully compound the concepts here, is equal to Ri. So what we're going to do instead is that we are going to go, right, so this will get, so I will be, so we'll go through the first row, then the second row, then the third row, index 0 row, the index 1 row, the index 2 row, the index 3 row, and so on and so forth, right? And what we'll do is, rather than just trying to work with it that way, what we'll do is that we grab array sub I. Now, yes, there are 2 coordinates, but if you grab one, you're just going to grab the individual row out of that. Remember, it's an array of arrays. So we can just simply grab that solitary row array out of there. And now what we can say is int j is equal to that, and then replace this row.length over there, and instead do row j. So ponder on that